session distinguished to explore. Uh, a
Hello.
session distinguished to explore. Yes.
Krishna Dayan बना
Yes, Mesa, continue.
To explore how AI is transforming real-world industries and creating impactful session. This amazing initiative is organized by Vita Nova Alliance for Science in collaboration with the Science Center for Programming Education. Vita Nova International is an international platform dedicated to promoting educational research and innovation by connecting professionals, students, and researchers across the globe. I would like to take a moment. Sincerely thank the entire organizing team for their hand-on experience, dedication, and efforts in making this valuable session possible. Your commitment truly deserves appreciation. This training focuses on practical applications of artificial intelligence, agriculture, healthcare, and research. It will give participants a chance to learn, explore, understand, and how AI can solve real-world problems and support data-driven decision making. Before we proceed, a quick instruction for all participants. Kindly mark your attendance by writing full name along with the serial number in the chat box. Now without taking much time, let's move toward the important part of today's session. We honored to having highly qualified and experienced professionals from different parts the world who will be sharing their knowledge and insightfuls with us. Our first speaker is Professor Engineer N.P. Chaudhary is a senior faculty member at Mehran University of Engineering and Technology, Pakistan. He has extensive experience in engineering, education, and research, and has contributed significantly to academic development and innovation. Sir, we are truly honored to have you with us. A very warm welcome to you.
Dr. Professor N.P. Chaudhary, you can start now presentation. Thank you. Dr. N.P. Chaudhary, it's a floor for you. You can start now.
Hello. Hello.
Hello, greetings, dear Professor. You can continue.
Hello.
Yes, am I audible? Dear Professor, am I audible?
Hello.
Hello, hello, greetings. Am I audible?
आवाज आएगा Hello. Hello. Yes, my voice is audible.
Yes, your voice is audible. Please continue.
Okay, may I continue?
Yes, you can continue.
Okay. Good evening to all of you. I'm Professor N.P. Chaudhary. I did my master's in this field of e-health and telemedicine systems from London. And to carry on with next slide. Next slide. So how to change the slides? Control is with you. Hello.
Yes, please continue.
So we shall be explaining this emerging trends in the field of biomedical engineering. So we have designed one of the low-cost implementation of the real-time vital sign monitoring, and in this one, this we have designed this one in the LabVIEW software using LabVIEW NI National Instruments LabVIEW software. Next, please.
Yeah, please continue.
So our prototype that deals with the data acquisition. So data acquisition or control that is designed for measuring uh, like blood pressure. So data acquisition and signal processing of vital signs using NI LabVIEW. So this project is actually the e-health system related to the e-health system, telemedicine based system. So we have designed algorithm virtual instruments using NI LabVIEW, where we acquired heart rate, blood pressure, pulse oximeter. So this blood pressure using pressure sensor, air cuff, and constant air valve that were used in this software that is being used for the students, mostly used in the laboratory. Uh, Another designs a sensor to measure the oxygen saturation, heart rate by using some of the red LED, blue LED, infrared LED, and the photodiode. So the later the sensor is connected to the National Instrument Data Acquisition System (DAC), and the measurements that are to be carried out in the form of blood pressure, in the form of pulse oximeter, heart rate. Next, please. So, these are our aim and objectives. So the objectives are to acquire vital signs, physiological parameters such as blood pressure, heart rate, and SpO2. So in order to interface the data with NI National Instrument Data Acquisition System. So we have a data acquisition system, a national instrument, telemedicine system, where we can connect data acquisition system to interface various sensors, or one can we can design these in the lab view that converts our data into the digital form. And finally, we have designed and developed a graphical user interface in the lab view to display the output. Next one. This is just an overview of the blood pressure, sometimes called RTL pressure, blood pressure that is exerted by circulating blood blood upon the walls of the blood vessels. So during heartbeat, during blood pressure varies between systolic and diastolic minimum, that is diastolic values, that is minimum, that is 80 millimeter mercury, and maximum that is 120 millimeter systolic. So there are some measurement techniques that must be known. Invasive, that is direct measurement, and non-invasive, that is indirect measurement, that is oscillatory method and oscillometric method. Next, please. So if you can see, this is a oscillatory method that needs stethoscope, and this is mercury that is used for all this for analog measurement. And there is another method that is nowadays oscillometric method, electronic pressure sensors, and where we can able to measure digital measurements, blood pressures. Next, please. These are some ranges of the blood pressure. Before we designed one of the prototype real-time vital sign monitoring. Students must know the blood range normal different with respect to ages, like infants 1 to 12 months, like systolic blood pressure that resides between 75 to 100, diastolic like 50 to 70. In this one, for the toddlers, for the preschoolers, for the school age, for the adolescents. So we all know these values. Next, please. So pulse oximeter. This is one of the device used to measure oxygen level, saturation level in the blood. And actually, our lungs that inhale oxygen and transfer this oxygen to the blood. And the lungs have dual functionality. Lungs also exhale carbon dioxide from the blood. So these are the some measurement techniques that were being used in the prototype. Oxygenated hemoglobin infrared LED. If we can see this graph, wavelength versus these are the levels, measurement levels. That is infrared LED, and there is a deoxygenated hemoglobin infrared red LED 940. This is below infrared. This is below the range that resides 940. This is oxygenated blood hemoglobin HbO2, oxygenated hemoglobin, and this is the normal hemoglobin that is without oxygenated, that we can call it deoxygenated. So this is a red LED that is 660 nanometers wavelength, that is about 660 nanometer. And if we can see this oxygenated hemoglobin like but this one red that is 660 nanometer, and this one about 9-10 nanometers, their their ranges. Next, please.
Yeah, continue, please.
Clear?
Yeah, yeah.
So next one is pulse oximeter. If we can say pulse oximeter, that is also used the saturation and the blood. And we have, so you can see we have designed this prototype, right, with red LED sensor and the infrared LED sensors. The photo sensor is there. Actually, I'm working from home today, but this device available in my office. Hardware is in my office, and so these are the current devices that are available in the market. So this LED, red LED, and blue LED, that is being these are for measuring of this pulse oximeter saturation in the blood. Next, please. Yes, these are some normal ranges of the heart rate, and we are familiar with this one. Just before designing this hardware, students must be knowing their normal ranges from newborn baby to adult. These are the current devices available in the market where we can able to measure even heart rate. Yes, next please. We shall come on the technical portion. Blood, this is blood pressure mechanism. Just this consists of air bulb, like this pressure control valve, hollow rubber, and one of the rubber tube. These are the components of this connected of the blood pressures hardware in the hard form. Pressure sensors and pressure cuff is there. Next please. This is a pictorial representation of the blood pressure cuff. Next. In this prototype, the red LED light emitting diode, and this is the pictorial representation of this one. And there is the infrared light emitting diode, and the photo transfer or photo diode that is used at PBX43. Next, they are used as a hardware. This is one of the hardware that is in my office. This hardware that I have given one of the project to the students, and this one. Next, please. So this work in data in NI LabVIEW is mostly we use this LabVIEW software as a virtual instrument engineering workbench where students can able to design platform, design VIs, and in this one there is a block diagram is there. There is a the front panels there where students can able to design VIs. Next please. One of the automated test equipment and the data acquisition system. Yes, this system converts analog waveforms into the digital values, and this also one can use for measuring blood pressure, cuff pressure, or controlling the pressure, blood pressure. And these are physically available in our laboratory. This is the NI compact data acquisition USB based, and the input output modules touch screen displays, and where students are working in this platform. Telemedicine, network design, and platform. Next, please. Is there is a user interface that is designed. So first of all, this one can able to enter the name and age of the patient of the user and prompt use for the input. This data that can be messaged that will be displayed over here, and the name and age will be in this that is used to input through the prompt user. Next, please. So we have a design in the NI lab view, data acquisition and control design for measuring and controlling cuff pressure. For example, in biomedical setup, such as blood pressure measurement. And this data acquisition, if we can come to the next slide, we have a VI. This is one of the VI. So if we can see, we have a data acquisition system that is used for real world signals from the hardware, like hardware that we have designed the prototype where one can acquire pressure, where there is a pressure sensor is there, and cuff pressure that is also to be measured, and there is a signal processing is there, and signal processing and conversion is there, and another one there is here is the constant that is used 37 for calibration of the this one for calibration and scaling. It means that will convert this voltage into the we can say pressure value in the millimeter mercury. And there's a web form is there, and that is graph display for real time visualization of how cuff pressure changes with respect to time. And we have a continuous signal monitoring in case of graphs that is being viewed in the lab view software. And there's a case structure. There's a pumping up. This is a case structure. Pumping up that is used for measuring. This is one of the measuring block that is used for decision making. So this is also that can be used for decision making. And there's a this one is cuff pressure millimeter and mercury. Pulse oximeter and heart rate. For pulse oximetry, we acquired two signals, one from the red LED and second from the IR LED, that is blue, by using single photodiode. So next, please. So this is another VI that is used for SpO2 and heart rate that we design in the NI LabVIEW software. Next, please. This is one of the whole VI of the project, mini project, or we can say it's one of the prototype that is designed for measuring real-time physiological monitoring. This next, please. Next. This is like a front panel, and this is in the LabVIEW software, real-time vital sign monitoring using the LabVIEW. So one can acquire heart rate, one can acquire blood pressure, whether up or down, with respect to name and age, and oxygen saturation level. in the blood, saturation in the blood. Next, please. Next, please. So overall, this prototype for low cost real time vital sign monitoring and easy to share and store. One can use in user friendly home environment. One can use in rural or remote areas, like telemedicine, where medicine delivered at a distance. Patients, user or patient can check vital sign routinely, or in case of any abnormal values. One can act as a expert doctor using this device as a distance for decision making. So one can contact available expert like telemedicine experts, maybe in big cities, where one can contact with radiologist, cardiologist, using telemedicine applications. Like if there is a problem with radiological radiology related, then one can establish teleradiology application. If there is a cardiac problem, then through this telemedicine tool, one can establish a telecardiology setup uh, in order to get expert opinion uh, from urban location to the remote location.
Thank you so
Thank
much,
you.
respected Dr. Anthony Chaudhary,
Thank you.
uh, for your wonderful presentation. I really appreciate your work in e-health system and health.
Can you type this one because I don't have a mic on my ears. So
Okay, okay, it's fine. It's
uh,
fine.
because I am just my voice, I think I delivered you people. But I
Uh,
tried to arrange the mic, but at the same time, I can't able to
okay, it's
clear
fine.
hear.
It's fine. It's fine.
Okay,
So thank you so much for your time and
okay,
for
okay,
wonderful
okay. Thank you.
presentation. Thank you. Have a good day.
Just any question, if one can able to message to me.
Yeah. If anyone have any question, you can write your question. We will provide the email of Professor N.P. Chaudhary. If you have any question related to e-health system, you can share your question on his email. Thank you so much. Is Miss Rumisa here?
Yes, sir.
Uh, okay, Miss Rumisa, you can invite Professor Dr. Edison.
Okay. Thank you so much, Professor N.P. Chaudhary, for such an insightful session. Now, I would like to call Dr. Edison Dure join us from Brazil. He is affiliated with the Federal Institute of Education, Science and Technology. With his strong academic background and international experience, he brings valuable insights into science and technology education. Sir, it is a privilege to have you with us. Welcome to the session.
Okay. Hello, everybody. It's a pleasure to me to be here present. I study with my students to share to the teachers and students who we are doing the research here in Brazil. That science is that we are doing here is initiatives that energize our students' minds and show how much science can lead them to a new discoveries. So we have three projects, three cases that I will share with you to have an idea how we handle this project here in Brazil with the students. We have students from the high school and from the engineer program. And basically, I'm a teacher of electronics, and I teach electronics and project with them. So we can start. Let's go. And please, next slide. This is our school. We have 53 schools like that here in our state, here in Brazil. We are located in São Paulo, in Brazil. Our school is more or less 1 hour by car from São Paulo, our capital in Brazil. And this is our school. And the next slide, I will show where the things go. The thing is, we make the projects make how can I say when we transform the idea and the na prototype. Please, next slide. Here is our lab. We have a class is a 6 square meter and is a lab maker. And in that class is a lab maker. We have laser cut, 3D printer, uh, manual tools, and we have tables where the students work on their projects. And we have the principal things that we need to do the project is the students is they are in these pictures, and all the projects that we developed on these rooms we focus to work on the last picture. We focus on the unit nationals. We have the OGD, is the 17 OGDs that we focus on that OGDs and in our projects. I can't believe the total projects we have one or more OGDs linked on them. Okay, please next slide. Here is how I work during the year on the project. These slides can show you that. We have the letter B to letter L. During this process from A to L, in 1 year, we spend 40 weeks, 40 weeks. And this is the time that we work in one project. And the ABC, the first three items, I talked to the guys from the administrations, is a job for the guys from the administrations. Is, for example, to have a space, to have a tools, is a infrastructure to work in a project. So the professor can't handle off on that. What is the job of the professor? Is from D, letter D to L. And this is our job. what is the advantage that what I find in this methodology? The most of methodology to work on projects from scientific projects, the documentation that you have, they work from G, letter G, to L. Is the middle. Is when we already have the title of the project. For example, if it is here, we will use the water 10 to work on that. Is the title that not came from the students. And this is not so cool when the title of projects came from other people. The best title, the best project that when we have good projects, the project must came from the students. That's the why we start on D letter, D, E, F. And I will explain why in the next slide. Before that, I will show some cases for you. Please, next, next slide. I have three cases to show you that was developed for students from high school. The first one is a Blue Clarity, is a project that my students they measure the clarity of the water and put this project in the ocean. So they measure the clarity of the water and send this data to the cloud. The next project, the number two, is a project that captures some images, pictures from we call the tick, but could be scorpions, crocodiles, rats, bats, and we can measure what kind of these animals or insects are in that space. And we use artificial intelligence to identify what kind of which one are present on that and send a report to the administration. And the last one is a project that we use a microcontroller to help the students to learn to read, identify letters, and then mailing. When we have a blind people, what is blind people? People that can't see, to identify the braille letters. So these projects help the people to learn read the normal letters and the braille letters without the professor. That's the biggest advantage of this project. Next, next slide, please. Please, next slide. Okay, the first project was developed by three students, Miguel, Samuel, and Maria Julia. What is the proposal, the project? When we start the project, we focus first in the problem. We look the problem. We observe the problem. First, the problem. After we identify the problem, how much bigger is the problem, we start to find a solution for that. So the first thing when we start a project with my students, we identify the problem. The problem. For this project, what was the problem that came for us? What the problem that we identified? With the manual measurement for the turbidity of the water in the ocean. How they do the measurement? One guy, one time per day, this guy go by boat in the ocean and measure manually the turbidity of the water and write in a paper the measurement and go back to the office. And they do not have a predictability. So this is a punctual measurement. This is the problem. This is expensive and depends of the day he cannot do this measurement. What is the solution for this problem? Okay, first the problem, and after that we find a solution. What is the solution? Is an automatic measurement use a sensors. So we developed this prototype that is in the picture. Is a boy that you have a sensor, and this boy is in the ocean, and you can measure in a real time, and you send this data by Wi-Fi, and you can use an artificial intelligence to give the prediction, predictability of this measurement. And you can cover a 100 square meter. And we are using a lot of network. So we are using a low cost microcontroller, and you can measure the total area of 100 square meter. This is the project that we are running here in São Paulo. That was done by these students. Next project, please. Next slide. This is the other project that it is a student he did by himself. His name is Adrian. This is a project that uses a camera, and we have a Raspberry Pi that we are using a program algorithm, a program done in Python, and you can take a pictures of the space that you are monitoring, and you can identify what kind of bugs or insects or animals are present in this space. What are the problems? We don't know what the pests are present in the environment. So we will start to film and identify, and the best thing of this project, we can quantify how many sets are present on that. What is the good thing of this project? When we send this information to the administration, we can find the best strategy to eliminate these bugs. In this picture, you can see the scorpions, rats, and the other bugs. And you can train the artificial intelligence to identify other animals. Can be, for example, if you can monitor birds, you can train the equipment to identify specifically this animal. This is this project. It was so good. Please, next one. This is that the project was done by these three girls. And what was the problem? We do not have techniques to teach braille for the braille to the blind peoples. And we developed these equipments. This camera, we are using the Key 10 from the Unihiker. We have a touch screen and camera integrated on this microcontroller, and we can take a picture, identify the words, and the intelligence artificial that the program that you have inside the board identify the word and send a sound of the word. For example, the first word that you have in these pictures is talk in Portuguese. Portuguese is fale, in English is talk. When you put this word under the camera will sonorize to the students, né? Or the user will talk, you sonorize talk. What is the advantage of this device? The student can learn by himself without the professor. For example, he can pick it and go with his home and study home with this device. And you can improve and minimize the time of study to learn the words or learn the braille. It can be used for the people that can see and people people that cannot see. Next slide, please. So here is, I will put a detail of the first three letters that is a of this method. The letter D, E, and F. What is the difference? And I spend 12 class. So what is 12 class? I have to find to determine the title of the project. I have to have 100% text. Oops, my presentation is not on. Can you show the presentation again, please? Hello? Guys, I'm not seeing the presentation. There, are there some problems? Okay, I will continue from my screen here. Okay, okay. I I conti- I will continue from here. So I'm talking about the letter D, E, and F. Letter D, we start to talk with the students what they know, what the knowledge that they came, the previous knowledge. For example, if what they what they know they do, what they, for example, if they have some expertise to assemble or disassemble some parts, they know some languages. I need some 3 or 2 classes to talk with the students to know what are the expertise that they have. So we talk with the class to know everyone and know what the previous knowledge that they have. So is a we talk to them. And the letter D, what we talk to letter D? E, letter D. We start to form some groups, to arrange groups to talk to start the brainstorm. What is that, the brainstorm? What we want to resolve, what we want to work for this whole of year. And for letter E, we spend for about 3 weeks. So we know what the students like to do. The next step, what they want to do. And the letter F, what they need know, what they want to do. And the question is possible we, our group, to resolve this problem? So we spend time in letter D, E, and F before we have our title of our project. So this time that DEF we spend 12 class. And after that, we start the normal, I can say the normal class for G to L. Okay? So this is aqui, this is we spend like 28 class, so you can finish the whole year of project. So ah, back. The important thing of this slide: spend time in order to find a good idea. Spend time. 10, 12 class. Spend time. The best idea came from students. If the idea came from students, so you have a sense of belonging. We have a key of success. A key of success. Again, I will reinforce that when we start a project, we have to start to in a problem, to be observant, analyze the environment. After that, I will find a solution, develop a project, a prototype in our field of knowledge, where I will be observed in a school, home, neighborhood, and to develop a prototype, Here in Brazil, we are using our spaces makers, our laboratories, so you can find a solution in each country. But the best thing to have a good project, first of all, is find first the problem to be solved. I will talk agora now. That is a surprise for this presentation. One problem that talked to me. The problem was how to analyze the vibration in the plants. Here we have a plant, and how can analyze that? We have a proposal. Identify the vibration, use a microcontroller that is here, is a Unihiker Key 10 that you have a camera, so you can take some pictures and you can monitor his movement, and you can calculate the vibration that his plate is on. And here is what we started. We have here the time 0 and next time of the frame of the camera is time 1. And here we have the center of the plan. Okay, okay? And next time the center moved to here. So we have a x, and well, and you can calculate the velocity and the acceleration. And the acceleration is a vibration. So we are using the Unihiker, and we have the camera 20 FPS. That the time between frames. We saw the best one to calculate the vibration is more than 20, but that's what we have. This is the code in Python that we did. And now I will ask to Samuel to show you what we have. Samuel, can you show your screen to the guys, please? Samuel? Samuel, can you hear me?
Hello.
Okay. Now you can share your screen and show.
Okay. Hi, everyone. My name is Samuel Lelis, and with my partner, Victor Santos, we developed the leaf vibration analyzer. We are 15 years old Brazilian students, and we study at Federal Institute of São Paulo, Campinas campus, in high school. As my professor said, the central question of this project was, can we extract meaningful vibration data, such as vibrancy and velocity, from photos of a plant? And I'll show you the answer is yes. This system uses a Unihiker Can-10 microcontroller with a built-in camera to capture a sequence of photos of the plants. As you can see on my image, we are taking the pictures and these frames are going to be transmitted to the computer through Wi-Fi and a local server. Then a Python backend processes those images, and finally, the results are displayed in an interactive dashboard. I'll show you my screen. Okay, for each frame, For each frame, the software first identifies green regions and then separates the leaf from the background using color segmentation. Then it removes visual noise and detects the contour of the leaf. That yellow dot represents the center of mass of the plant, called centroid. It's the geometric center of the leaf. Once the
Samuel, eu não
centroid,
tô vendo a tela, Samuel.
oh, deixa eu tentar compartilhar. Can't you see my screen?
Não.
Can you see it right now? Because I'm already sharing my screen.
Você selecionou qual a tela você quer compartilhar?
Yeah, for me it's showing you.
Tenta de novo. Eu fui no apresentar, slides, aí eu selecionei o seu computador, aí eu pus a tela.
Eu também, já coloquei, tá parecendo que eu tô apresentando.
Ok, vou perguntar aqui. Hey guys, can you see the Samuel screen?
No, sir, screen is not visible.
Não estou conseguindo, Samuel.
Okay. Can you
Ok,
see me
ok.
right now?
Yeah,
Okay.
ok.
So I'll restart. Let me see. Okay. So first, for each frame, the software first identifies green regions and separates it from the background using color segmentation. Then it removes visual noise and detects the leaf. From each frame, the system calculates the centroid, which is the center of mass of the leaf, represented by these yellow dots. Once the centroid is found, the first image tracks the frame frame by frame. We use some classical mechanics formulas to calculate vibration, and then, I'm sorry, you can see the system working. Using the frame rate, we know the time interval between images, so we can calculate vibration using a mathematical tool called fast Fourier formula, or FFT, that converts movement over time into movements by frequency. Basically, it tells us how many times per second the oscillation cycles occurs. I'll wait for the processing. The strongest peak of the dominant vibration frequency is in hertz, calculated by the fast Fourier math. Finally, all computed variables are exported automatically to a JSON file, and then we can see the results on the website we developed. Here we have the dominant frequency of the vibration, FFT amplitude, spatial amplitude that represents how many physical pixels did the leaf actually move it, and frames analyzed. Here are the graphic of white placements of the fast Fourier formula, the centroid trajectory, FFT spectrum, and then we finally with velocity per frame and acceleration per frame. Here we added a simple diagnosis that shows us how many times per second the leaf is actually moving. The system indicates that it's a nearly static leaf. So to summarize, we developed a low-cost complete computer vision pipeline that takes a sequence of images as inputs and outputs quantitative vibration data such as frequency, amplitudes, and even velocity without requiring especially an expensive physical sensors.
That's all? That's all?
Yeah,
Okay. Thank you. Was great, 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 great. Thank you, thank
thanks.
you. And just to finalize my presentation, I have just one more slide, and the last one is this one. So, guys, thank you, and this is what you are. Is the last one. The last one. The last one. The last one. Yes, thank you. That's what we are done here in Brazil with our students, and we are open to cooperate with you to exchange knowledge. And if you have some question, you can write us, and we are able to help us together. Okay? Thank you. Okay, we finish.
Hello, can I begin now? Hello everyone. I hope you are doing well today. Today we will talk about artificial intelligence and its different fields. In particular, we will focus on an important application of AI, which is using artificial intelligence to detect plant diseases. The idea of the system is simple but very powerful. A user can take a photo of a plant using a mobile phone, and then the AI system analyzes this image using advanced image analysis techniques. After analyzing the image, the model can determine whether the plant is healthy or infected, and if it's infected, what type of disease the plant has. In addition to that, the system can also suggest possible treatments or recommendations to help protect the plant and improve agricultural productivity. This type of system is widely used today in what is known as smart agriculture, which is one of the modern fields that combine technology with agriculture. Next slide, please. Now we will focus on the branch related to plant detection. What is plant detection using AI? It's the use of AI techniques to identify plant species or detect diseases. The basic idea: use the phone of the plant as input and the system determines the plant type, whether it's healthy or infected. If infected, the disease type. Why is the branch important? Next slide, please. Okay, smart agriculture relies on early disease detection to increase yield and reduce losses, help farmers and researchers make quick and accurate decisions, reduce reliances on human experts alone, making solutions faster and more efficient. How does the system work in particular? How does the system work in practice? A user takes a photo of a plant or a part of it, like leaf, using a mobile phone. Then the image is sent to pre-trained AI model on mini plant and diseases image. The model analyzes the image using computer vision and deep learning techniques. The system provides results that results plant type, disease type if any, sometimes suggested treatments. We will talk about real world examples such as PlantSnap, PlantNet using home gardening, commercial farms, scientific research. Next slide, please. Okay, now we will talk about computer vision. Computer vision and deep learning. What is computer vision mean? Computer vision (CV) is a branch of AI that allows computers to understand images and videos like humans. The goal of computer vision is to extract important information from images such as leaf shape, plant color, leaf edges, leaf patterns, or spots. In our project, computer vision is the technique that will analyze the plant image captured by the user. The system converts the image into numerical data pixels and processes it to extract meaningful features. Then we will talk about deep learning. Deep learning (DL) is a type of machine learning that relies on artificial neural network, especially convolutional neural network (CNN). CNN. These networks can automatically recognize complex patterns in images without manually programming rules. In our project, a deep learning model We learn to distinguish between healthy plants and diseased ones. It will also differentiate between different types of plant disease. The model learned from a large label dataset of images. Okay, next slide. Okay, now we will talk about how to use them together in the project: computer vision and deep learning. First, data collection. Data collection take photos of plants or use a dataset like Plant Village. Each image must have a label indicating the plant type or disease. Second, image processing. Image processing resize images to fixed dimensions, normalize color or lighting, remove background if needed. Then deep learning. Deep learning model use a CNN for image classification. After that, inference. Okay, next slide. We will talk about layers of CNN. The first layer, conventional layers that capture simple patterns like edges. Second one, pooling layers. Reduce image size while keeping key information and fully connected. And the third layer, fully connected layers, make the final decision about plant type or disease. After that, model training. Feed the labeled image to the model to learn. After several epochs, the model improves and can make accurate prediction. Model evaluation. Next slide, please. Okay. After model training, we will talk about model evaluation. Model evaluation tests the model on new unseen images. Measure accuracy to ensure reliability. After that, model inference. Model inference make user takes a photo of the plant. The image is fit into the model with outputs. Which outputs? Plant type, whether it's healthy or disease type if any. Sometimes suggested treatments or recommendation. Now we will talk about a practical example: plant disease detection. We will talk about the dataset, model, training, and prediction. First, dataset. Imagine we have images of two plants, mint and rose. Some images show healthy plants, others show diseased plants. Its image has a label indicating plant type, healthy or diseased. Dataset means collection of images with labels. Then, second is model. Model is the intelligent system that will learn from the image. In this example, we use a CNN. The model learns ages, leaf shapes, spots, or changes in the plant. Model means the system that will learn from the dataset. The third step is training. Feed the labeled images to the model to learn patterns. The model looks for common features in each category. After several rounds, epochs, the model improves. Training means teaching the model using a dataset. So, training means teaching the model using the dataset. Number four, prediction. After training, we test the model in a new unseen image of a plant. The model outputs Plant type, healthy or disease. Disease type, if any. Prediction using the model to predict on new dataset. Next slide. Okay, now we will talk about this table. No, no. Okay, thank you. Dataset. Dataset labeled bland images. Dataset dataset mean labeled bland images. Model means system that learns from images. Training means teaching the model from the dataset. Prediction. Prediction means predicting outcomes on a new image. Now we will use the Teachable Machine website to create a simple demo and understand how to build and train a model. Can I use the Teachable Machine? Can I make an example on Teachable Machine? Can I present from my computer, my PC?
Yes, ma'am, you can.
Okay, now I will open Teachable Machine and present now. Is it clear now? Can you see screen? My screen?
No.
Okay, now you can see Teachable Machine website.
Yes, yes.
Okay, thank you. Okay, now we will make a practical example. Before the session, I download the images in order to save the time. At first, we will label the classes. Can you make a new project from here? Then there class 1, class 2. If you want to add more classes, you will press here. Class 1, I will say healthy meant, unhealthy meant. Now you can take pictures from camera or upload them. I will upload from my PC. Okay. Now I have a 56 image. Now I will upload unhealthy. Okay, I will start training, but I will see my epochs. If it will be more accurate. You will have more accurate result, but I will make it 50 in order to save time. Patch size 16. Okay, now I will start training the model. When it finished, I will use images to test. Okay, now I will export image to see it's healthy or not. This for exporting your model to use it in code. If you want to make it in programming code to test it healthy or not. Okay, now take I will upload image like that. Okay, it will give me the output. It's unhealthy mint. If I upload next one, okay, I will take that. Okay, it's a healthy mint. You should take a model, export this model, and use it in your project to show what is the type of disease and how to solve it. Thank you. Now I will stop screen. Okay. Okay. Can you present the slide, please? Okay, no slide here. Can you present the slide, please? Presentation is out. Next slide, please. Next one, please. Okay, thank you. In conclusion, today we saw how artificial intelligence can help us understand images and make accurate decisions. We explored its main fields such as computer vision and deep learning and how they can be applied to detect plant diseases. We also learned that proper training on a large dataset leads to more accurate results and that such system can be used particularly in smart agriculture to assist farmers and boost productivity. I hope this lecture gave you a clear understanding of the power of the AI in real life application and its future potential. Thank you. If
Thank you.
anyone have any question, feel free to ask any question to me. Thank you.
Thank you, Engineer Amira Atala, for presenting such an amazing presentation. Now I would like to call Fatma Mustafir Amir, our final speaker from Southeastern University of Sri Lanka as a senior lecturer. She has a strong background and has contributed greatly to education and research. Ma'am, it's an honor to have you here. Welcome to the session.
Am I audible?
Yes, ma'am, you are.
Okay. So, shall I share my screen because I also have some demo to show.
Am I
So, shall
audible?
I share my screen and
Am I
share the
audible?
slide myself? Yeah.
Yes, sir,
Okay.
you are.
Thank you so much, Miss Amira Tola, for your wonderful presentation and for a practical demo. That's very helpful for us for precision agriculture system, student and researchers. Uh, if anyone have any question, you can write on your notebook, and we will share the email, and you can ask your question on the email due to shortage of time. So you have to write your question. We will provide you official email of our speakers. Thank you so much, everyone, for your attention and for your interest, taking interest in deep learning, machine learning. Yeah. Thank you so much. Next.
I would like
invite Miss Musafira Amir. Uh, I would like to invite you, Miss Rumesa Sajid. You can continue.
Yes, sir. Sir, I have invited ma'am, and she said that she want to present something.
Yeah, sure, sure. Uh, is
Is my screen
is
visible?
Yeah. Let me share your presentation.
No, I shared my screen. So if it is
Okay, okay.
visible, I think that I can manage. So just let me know in the live, is my slide visible or not?
Uh, yeah, now visible.
Visible. So I'm just
Yeah.
showing my presentation in my screen. It's a PDF opened. Yeah, visible, right?
Yeah. Thank you
Yeah.
so much. You
Oh,
can
yeah.
continue.
Okay. Yeah. Okay. Thank you for the opportunity. So it is my pleasure to be here for this hands-on artificial training program organized by the Vitanova International Alliance for Sciences. Thank you for the opportunity to be here. So the last three presentations were really awesome. The first two were really giving the idea on the way we should see to address the problem existing across the globe now. And the engineer Amira presented in such a way that AI can be used in agriculture. And I have used the same data set and the plant diseases and teachable machine also. But anyhow, I have a backup plan to continue with the presentation. And thank you, Engineer Amira. So it's me, Fatima Mushfira Amir, as the sir introduced. I'm the senior lecturer attached to the Department of ICT from Southeastern University of Sri Lanka. So yeah, so I'm not going to touch more on theory, but just I'm touching quite few details. Okay, so as we all know that the importance of agriculture is very well known across the globe. So globally, over 820 million people still suffer from hunger, and the same time the global population is immensely increasing, and we will need a 70 percentage of more food by the year of 2050. So as the future leaders, as the researcher, as an academic, as a people in the globe, we should find out a solution using the available technologies to overcome these issues. Okay, so these problems are not just a technology problem. This is, I would say, a survival problem which need to be clearly addressed. So what is AI? Already it's been explained, but just let me um, like a recap. So AI is something which learns from the data. So data is the key for AI. Without data, we can't just think of a word AI. So AI is something that it find patterns. For example, it can identify patterns in soil, it can identify patterns in weather, it can identify patterns in crop conditions, etc. Not only in agriculture, in healthcare, in anything. If we have a data, we can identify patterns, and using the technologies provided by AI, we can identify patterns, and using that pattern, we can support decision. So, as a third point, I would say it support decision. So it helps us to make better and faster decision based on the identified pattern. So, in simple word, I would say that AI is mainly data plus pattern plus decision. So why agriculture is need? So just I'm going to skip it out in a GIF. So in order to meet the SDG goal, agriculture is crucial for achieving more than 7 plus SDG goal given by United Nations. So, what AI really does? So, AI learn from large data patterns. it improves decision faster than the humans. So, for example, a farmer may take a days to inspect an entire farm manually, for example, to check the soil, crops, and condition. But if the farm is integrated with AI, the same task can be done in minutes using technologies like drone, IoT sensors, and we have more. So AI can even exceed human performance in specific tasks. For example, when it comes to immense amount of data, a human can't process that data quickly. So an AI can. So AI is uh, not it is not replacing the human. So AI is really supporting humans to make faster and better decisions. So, real world AI applications, we have more like crop and soil monitoring, pest and disease detection, weather forecasting, just to predict the weather patterns more accurately. Okay, so based on that, the farmer can plan better what to do on that weather condition. Yield prediction, so AI can estimate how much crop will be produced even before harvesting, so they can make some market strategy just by predicting that. So AI is not the future; it is already used in real farm today. So in more advanced systems are being used across the globe now. Okay, so this clearly shows that AI is not something for the future; it's really happening in today's world. So, what is the real impact? So the program says precision agriculture. What is that? So precision agriculture means with the help of data or using data, AI can make accurate and optimized decision to improve the yield, to reduce the cost, and by doing these stuff, it can ensure sustainability. So it can help protect the environment while increasing the productivity. That is called sustainability, which is the UN goal as well. So AI can be used for that. So this is the AI ecosystem. So it is just a diagram to show one of the flow, what is really happening. So first we start with sensor. Okay, so sensors, we all know that, So these are some devices placed in farms to collect the real time data. For example, the very basic stuff is soil moisture, temperature, and weather conditions. And the data is sent to the cloud or other technologies where it can be accessed. The data can be stored, accessed, and processed. Then it come to the AI come to the picture. It analyze the data to make the better decision about the data. Based on that, the decision will be made. So this is the flow of how the AI ecosystem really work. So it is AI created image. Okay, it's just the AI powered precision farming. Um, it just show the advanced view of how AI works in agriculture. So we have drones and we have satellite here that capture the images of the entire farm to collect the data from the ground sensors, such as I said before, the farm conditions, starting from soil moisture to nutrients to environmental condition. Then all these data will be combined. Then AI will process to detail farm maps, and insight will be created. So this is how the AI works. And we have challenges as well, like connectivity issues in rural areas, since it need internet. For example, IoT, we need internet, and we have digital divide, the infrastructure problem, the data collection is really having a high cost. So these are some challenges there. So this statistic shows that the AI in agriculture market has grown from 1 billion in 2022, $4 billion by 2026. So this shows that AI in agriculture is not just a research topic that we do. it is rapidly growing as an industry. Okay, so this growth creates huge opportunities for research, innovation, and even for job opportunities. So especially for students and professional in the field like um, IT or agriculture or data science, there are more job opportunities and clear demand to invent more. The real application in agriculture, so these are the available tool. So since the time is limited, I'm going to touch everything more in detail. So these are some tools which uses AI technology. It's already available in market. So there are functionalities, the technologies being used, and the impact, and the comparisons. So it's been given here. So this slide is from Microsoft presentation. So it clearly explained about the open research problem to enable data analysis for small scale producers. So it clearly shows that even the AI exists, there are some problem to be addressed. So that opens another door for AI research. So, from real system to your hands-on. So, the real AI systems are using data, models, prediction, and it uses the data set. Using the data set, it train a simple AI model and it make predictions. So that is how the AI really works here. So today I'm gonna introduce three tools. So the teachable machine's already been done. So I'm gonna skip that one. So the first tool that I'm going to show you a simple demo today is the Google Colab. So this is a coding based platform where we can build AI model using Python. Just I'll guide you step by step procedure to do that. And second one is the teachable machine. It is the no coding tool where you can train AI just by using images. Very simple and interactive. As I teach you, it can teach you how AI really works. And the third one is I personally prefer this tool for the visualization. So not only the techno people, so even the social scientists can use this tool immensely to understand the data pattern in their own perspective. So this is the visual AI tool. You can build models just by drag and drop. You don't need to even type a single code there. Just drag and drop. You can do that. You can connect the blocks. No coding is required. So you can do prediction using this tool as well. So whether you like coding or not, there are plenty of tools here for every. So AI is not coding. AI is when I talk about AI to the people who are not from IT, for non-IT people, they will feel I don't know Python, I don't know coding. So how can I do that? It is not. There are plenty of tools available. You need to understand the basic concept. How does this AI really works? If you understand the concept and few algorithm, that's fine. You don't need to even code. So that is how the versatile tools exist in the tech world. And I told you that the data is the key. So we need to collect the data. So that is the main part of doing AI system. But many data repositories there. The famous one I use for my class is Kaggle. So we have large collection of data set for AI, agriculture, healthcare, and more. And UCI machine learning repository. And for agricultural data, you can use a FAO, World Bank data sets. Plenty of sites are there with full of data repositories. You can collect the data there, but we have to keep it in mind, whatever the problem that we address, the data should be specific to that domain. For example, I'm from Sri Lanka. If I want to train a model for a crop prediction, I need to use the data from my geographical location. I can't just use the data from the Kaggle. If the data is belong to European country, it won't work. So we have to keep, be mindful or cautious on the data that we use. So that is the key thing to mind. So So I'm going to show you a few demonstration. If you are ready, the participant, you also can follow it up. It is very simple. So nowadays, today's Google Colab is linked with AI. So we just need to pass some prompt. No need to understand the coding as well. So I just prepared my presentation from the perspective of that I'm presenting for non-IT. So that is for the beginner level presentation only I prepared. So we just need to go to a Google Colab. Is my screen visible now? Can you able
Yeah,
to see
visible.
the?
Yeah, visible. Continue.
Okay, so this is the Colab site. You can go to that site and you can just create the new notebook. Participant can follow it up if they are on PC or whatever. So you can rename it if you want. So this is the workspace to work with Colab, right? So here we can just write coding of our own, or we can generate with AI, which is a very good feature for non-IT people. So for this one, we need to have a data set. So I have downloaded a data set from Kaggle, which is this crop recommendation data set from Kaggle. I have downloaded already. So this is the data set that I'm going to use today. So it has 8 field with variable nitrogen, phosphorus, potassium, and the temperature value, humidity, pH, and rainfall. Based on these parameters, this model is going to predict which plant or which crop can be planted there based on the condition. So this is what our model is going to predict. So it is a very simple demo. So first we have to load the data set, our file to this Google Colab. So you can start, coding, or else you can just use AI, generate with AI to load the coding. So just I'm giving a prompt, having the perspective of non-IT people are there, so it will be helpful. So just uh, load the coding to load the data set. So if I run that, so here the coding AI has already created the coding. So if I run this one, it takes times. Okay, no, sorry. It has the error, so I just delete that one. Maybe give me some time. Or let me type the coding. Wait. Yeah, here it works. So it is just the matter of giving the prompt. So here we can choose the file. So where we have stored the file, we have to go and you can choose the file. There are many ways. You can just directly use the file name to upload the file as well. Just I am telling the way to use AI to do your work. So our file has been data sets been uploaded to Google Colab. Okay, so this is our data file. The first 5 rows been displayed here. So you can check with the data set. All the field are there. So you can check the data size. You can check the headers and everything. We can check there. So if I have time, I can just explain what the data frame, what is PD, and everything. But since the time is very limited, I'm just skipping all the detailed explanation of the coding. So we are going to train the model using this data set that we have uploaded. Okay, so just I'm gonna pass another query to have the to train the model. Okay, let me pass a query using this data set. Uh, write code to train a random forest model to predict the crop labor. Maybe I would say like that. Using NPK, the field are there. NPK, temperature, humidity, pH, and rainfall. I'm sorry, I have used the caps lock. I'm sorry. Yeah. So if the random forest is the model, a machine learning model that we use to train this, uh, what's that, the prediction. So this model is quite a powerful and widely used machine learning algorithm. So it is like asking opinion from many to make the prediction. Like for example, if we want to predict the crop manually, we need to ask from many farmers, okay, using this condition, based on this condition, which crop I can plant. So we need to ask from many farmer. So that is how this algorithm really work. Random forest means that it creates many decision trees behind and combine their results to make the final decision. So we have plenty of algorithms. So random forest is a quite a popular one to do that. Okay, so when I click this one, it will create the model. So our models being created. Let me run. So our model has been created and the it has been evaluated successfully, and we have some key term accuracy. So accuracy is something, it's like 99%. It means like how often the model is correct. So few key terms we have to understand to interpret the results that we are doing here. Okay, so we can use this to manually change the values. For example, from the data set, we have given values of uh, nitrogen, phosphorus, potassium, temperature, and all. But our model has to work for our given scenario. So for that, we can write the coding here to randomly change the values. So we can predict the crop that we want to plant. Okay, so write coding to uh, adjust the values and make prediction um, prediction of crop. Let me. So here we can adjust the values and change, and we can use our creativity to make it done. We can create an output with slide bar if we have the prompt like that. But here, for example, here nitrogen percentage is 90, phosphorus is 42, potassium is 43, and we have pH value like that. So based on this condition, so the predicted crop is rice. We can change and check. For example, I'm changing the rainfall to 45, maybe. So let's check whether the output is changed. Yeah, if the rainfall is reduced, the predicted crop is watermelon. So we can pass our variable based on our current condition, and we can predict the crop to be planted. So this is very basic. This is how this AI model works. And using this AI feature, you can play around, you can work with whatever the thing that you want to do with data set, and whatever the perspective that you want to have the output. Hope it is clear. So I can show you more example, but due to the time constraint, I'm just skipping out that. And teachable machine, I have prepared a demo. Since it's been already done, I am skipping that one. The next one is the orange data mining tool. It is the drag and drop AI tool. We don't need any coding knowledge in prior. We can use this orange data mining tool for data analysis and machine learning. It has a visual workflow and easy to understand by that one. So this is the site. If you can go to that site, you can download the software. It is slide. You can, if you click download, it will show you whether you want to have a window or Mac version. So it's a very basic stuff to download. I have already installed the orange tool in my lab, so I'm gonna just show you. So if I open that, I get a workspace like that. Okay, so I'm gonna create a new project. So here we have different widget here: data widget, transform widget, and visualization widget, model and evaluate, unsupervised. We have different widget, and from device to device, based on the operating system condition, some flow may change, but these are the basic feature. The same thing that we have done using Google Colab, we can do this using this orange visualization tool as well. Okay, so I'm gonna upload the file. So I just click the file. We can do drag and drop, or you can just click. So this is the file. So if we double click the file, you can upload. So I already uploaded the crop recommendation data set. You can just simply click this folder and upload your file. And these are the variable. Okay, this nitrogen, phosphorus, potassium, everything is numeric variable, and these are the feature. And you can change if it is categorical, and if it is text, you can change that. Since it is numeric, I let it be. I'm sorry, let it be. And this is the feature. Here only one thing that you have to consider: which factor we are really checking. That is categorical. The label mean the crop name in our data set. Here, that is the label. This one we are going to check. This one, based on this condition, which crop we can plant. So this one, so that is a category, and that is the target. We have to change this one, and we have to apply. When we click apply, I have applied. Okay, so yeah, the file's been uploaded. Then we will train the model. Wait, model. And here also we are going to use the random forest. So I'm gonna drag and drop this one here, the drag and drop. So here you can see only one side circle is here in file, and in random forest we have two end here. Why is that? Is in the file we have only output, we don't input here. In random forest, for the model, we can give input and we can get output. For that one, we have these two side semicircle here. Okay, and we have to connect that. just click and connect that. Okay, so the file, the data is connected with the model. Just drag and drop, simple as that. And if you click that, I'm sorry. Wait. So it doesn't. Yeah, random forest. And we have to we have loaded the model, and we have to make a prediction. So we have to drag and drop the prediction. I forgot that one, I'm sorry for that. So prediction, where would that be? Yeah, prediction. So we have to predict here. So we drag and drop the prediction. So we have to connect this one to prediction. Okay. So if we click that one, it can show the possibilities of the prediction here, right? If you want, the model will be trained and show the based on the available parameter on the data set. But if you want to input our values as we have done in the Google Colab, we need to share a data table here. Data table, let me show here. Yeah, we have to insert a data table, and we have to connect that with this file and with the prediction. Yeah, and using an Excel sheet, when we import an Excel sheet to this one, like in the Excel sheet we need to have our parameters of, to which parameter we want to check for the prediction. So that is how this orange tool is quite easy to train the model, right? So you don't need to code anything, just you need to have a data set, and you just upload this using the file, and connect that with the model. We have plenty of model based on the problem domain. You can drag and drop the model there, and you just connect with the prediction, so it will make the prediction itself. Okay, then if you want to pass any values for some devices, if we click the prediction it will work, or else you need to create a separate Excel sheet and create a the column as this. You just have your preferred value there, and if you pass these I'm sorry, if you pass these to this data table, it will do the prediction, and the prediction model will be shown. Since the time is limited, I'm not gonna show that one. So this is one of the easiest visualization tool that you can use to train the model. Okay, so yeah, and live demo I have already shown that. The future vision would be the smart farms. Already it's been developed, but since there are problem to be addressed, in terms of smart farm. And AI and IoT integration, it's happening now. IoT is something that we use sensors to get the data and pass to the cloud and make decision based on the data that we got from the sensor. But since it is connected to AI, it can work more. It can address more problem. And autonomous farming system, climate resilient agriculture, because the climate changing is one of the main problem that our globe faces now. So the agriculture that we need to undertake should be climate resilient. For example, based on the climate condition, we need to choose a crop to plant, then only the yield will be maximum, or else the agriculture will not get succeeded and the production will be low. And AI powered decision support, starting from factory to food processing to farming, watering, the harvesting. AI powered decision support systems are already being developed, and there are plenty of problem to be addressed. As you are a working professional, I'm not sure if you are a student, if you are hoping for a research gap to address the problem in agriculture, there are plenty of opportunities in terms of climate resilient agriculture, which is that many organizations are now addressing, and they are calling for many proposal to fund if you are come up with a good solution to overcome from these problem. Okay, so as a final message, I would like to show, I would like to tell you, AI is not replacing agriculture, it is just empowering it. So empower it, empower the agriculture. And thank you for the opportunity and thank you for the attention. If you have any queries to ask me, you can reach me out through this email. Thank you. Thank you so much. I'm done with my presentation.
Thank you so much, dear Musafiro, Amir, for your wonderful presentation in the domain of Persian agriculture, which is very helpful for the young researchers and early career students. And I really appreciate your work in this domain in the region of Sri Lanka. And I really warm welcome to you to discuss more in upcoming future projects within White Nova International Alliance for Sciences. Uh, I would really now we have to conclude our this session. If anyone have any question, you can still write in the chat box. We are still ready to give you and address your questions. If any question is in your mind, we will answer it to you. And I really also appreciate the efforts of audience to keep in touch throughout the training, like from different countries, experts sharing their knowledge, and Miss Laiba, I think you joined very late. First presentation was about the e-health system. We will provide the recording. Those have missed any part, they can again review the core presentation. Yeah, and yeah, we will share the presentation into the group. And still, if anyone have any question right now, you can ask. Otherwise, we have to conclude our today's session. And for the final remarks, uh, I would like to invite Amira Atala. If you want to say anything to the audience, a floor for you, Amira.
Hello.
Yes, yes, continue.
Thank you. I don't need anything. I'm sorry. My PC is my network is off. So I entered again.
Okay, it's fine. It's fine. So, further, I would like to invite Miss Musafra for final remarks, and then we will move forward.
Yeah, I thank you so much for this wonderful opportunity. So it really feel great to share our thoughts and to make a little contribution to make some insight on the audience. I seriously don't know about the the audience level, whether they are the students or professionals. So I was quite unaware of that, but I'm really seeking for future program like this, which is quite more in detail way. Half an hour, 30 minutes is not enough for the live demo. So if it is around maybe at least an hour or 2 hour, that would be really helpful for us and for the participant to give a very fruitful hands-on experience. And I'm expecting from you to arrange a kind of a detailed hands-on session in future, so that we can contribute in a very meaningful way. But
Yeah, yeah,
today's
for
session was
sure.
really awesome, and I really got some insight from previous presentations, and these speakers were really good. And thanks for them. And it's really nice. And I just got some insights, and I'm gonna, yeah, thank you. Yeah.
Thank you so much for your final remarks. From from the Sri Lanka. Which area of Sri Lanka?
So I'm from Dintavur, which is the eastern side coastal area. Our university is attached to the eastern province. So I'm residing there, which is a beautiful village. You should come one day.
Okay.
It's a
Oh
very
yeah.
nice place.
Obviously, we will visit in future. Hopefully, yeah.
Yeah. We will work more.
And really nice to meet with
Yeah.
you, Amira, you, Musafa, and other all Dr. Professor Edison and Professor N.P. Chaudhary was discussing EL system, and really nice to meet with all the students and participants from all over the world, from different region of the globe. I really appreciate you for a passion for learning, and we are looking forward for further meaningful events and projects, and hopefully we will make a more details practical sessions with Amira and Miss Musafra in future, like on practical training sessions in
Yeah.
details.
Yeah.
Amira, if you have any question in your mind you want to discuss.
No, thank you. I'm very happy to be with us today, with you today, and I take to with you in another session. Thank you.
Thank you so much for your kind word and for your wonderful practical session as well, along with Miss Amira. And thank you so much, everyone, audience and organizing team, Miss Romesa, marketing manager at Vaitanova International Alliance for Sciences, Mr. Mansoorul Haq, technical manager and deputy director at Vaitanova International Alliance for Sciences, and Miss Hafsa Sarfraz, vice president at Vaitanova International Alliance for Sciences, for organizing this wonderful opportunity for the students, learning platform for them. And I really appreciate the efforts of everyone to make that AI training sessions meaningful way. And thank you so much again and again, and have a good day with good night. So if I talk about the if I talk about the certification, you will get your certification within 27 hours of this session. Okay, our teams are working on it. So those member attend this session, we will provide them certifications. Thank you. Especially, I would like to especially thankful to Mr. Kofaitullah. He is very like passionate learner from the region of Balochistan, a backward area in Pakistan. Like the students and researchers from all over the world, those belongs to backward areas that are wonderful opportunities for them for learning new things in the field of biological sciences and allied health sciences. Uh, we will make more opportunities for the student and young researchers to make their portfolio, to improve their portfolio, to build their portfolio in future. And at the next moment, I would like to conclude this international training session at this. Thank you, everyone. Have a nice day.
Thank you so much. Have a nice day. Good night.
Good night. Take care. Bye bye. And Miss Mesa, are you there?
Yes, sir.
Okay, if you want to say at the end to the audience.
I would sincerely thank to our speakers for their valuable insights and the organizing team for making this event possible. Thank you all the participants for joining and staying with us. With this, we conclude today's session. Have a great day ahead. Allah Hafiz.